Hello guys, welcome back to ptet.chemistry channel. So in this tutorial channel, I'll go through this topical test which is supposed to be taken in 50 minutes to 1 hour session. This is for 40 questions multiple choice. They are all topical questions on the 14 to 16 years old O-level or the IGCSE, which is equivalent to O-level chemistry, and this is specifically on chemical structure and bonding kind of topic. Okay, so in this first question, we have the diagram showing you the molecules of 3 elements. So there are 3 elements because elements consist of only one type of atoms, and this is a single atom. So this usually refer to the noble gases. The noble gases exist as monoatomic gases. So this refer to the noble gases. Mono refer to one, atomic because they exist as single atom. So if it exists as single atom, there's only one type of atoms, therefore it's an element. This is an element, but it's a molecule. So this is actually called a diatomic because di refers to 2. So diatomic means 2 atom. 2 atom in this molecule. The 2 atoms are exactly the same. So there's only one type of atom. So this is an element. So here, this is another molecule. This is another diatomic molecule because it's got 2 atoms. Both atoms are the same type, so it's also an element. But here you have double, meaning 2 covalent bond, 1 and 2. Here you have single covalent bond. So which of these elements are present in water? So water is a case study as part of your structure and bonding under covalent bonding. So we are looking at oxygen gas and hydrogen gas, where they exist as diatomic molecules as an element. Both of these exist as diatomic molecules as an element. So we're looking at 2 and 3 and not the noble gases. So 2 and 3 will be option C there. Question 2. So we have another model here. So this model has these black things there, and you can see they contain carbon, hydrogen, and oxygen. Carbon is from group 4, so these are the Roman numeral as per the international standard to represent group number, and group number tells you the number of outer shell electrons. Group 4 meaning carbon has 4 outer shell electrons, and therefore these are forming bonds to the other non-metal. So that's why these are covalent bond, because covalent bond is formed between non-metal atoms. And because it's covalent bond, you can count covalent bond. So this is a central atom. It forms 1, 2, 3, 4. It forms 4 covalent bond because it does the 4 plus 4. So it shares 4 of its electrons, and it managed to share another 4 more from each of the 4 other atoms that it formed covalent bond with. That's why we are looking at the black one. The really, maybe I should draw using a different color. Let me try this one. So the black color one, we are looking at a group 4 carbon. So you can see the carbon form 1, 2, 3, 4 covalent bond, and this must be the hydrogen. Hydrogen forms single covalent bond, so this must be hydrogen, group 1 hydrogen. So I've described hydrogen as a group 1 element, even though it's not a metal, but it's got 1 outer shell electrons that is in the first shell and only 1 electron for hydrogen atom. We could consider as group 1 because they contain 1 outer shell electrons, even though it's not a metal at all. Alright, so hydrogen form a single covalent bond with another non-metal. So that must be hydrogen, and the other one is oxygen. So this one must be oxygen. And oxygen is group 6. Group 6 means it will form 2 covalent bond. It can form 2 covalent bond between itself, like oxygen. So group 6 outer shell electron, share 2 of the electron. It managed to get another 2 by sharing it from another atom. So 6 plus 2, 6 electron that belongs to you, plus 2 more electrons that you share from the other neighboring non-metal, give you a fully filled outer shell. These are from atomic structure as part of the syllabus required by the Cambridge. Okay, so what we have then is we have oxygen in group 6 that form 2 covalent bond, 1 and 2. So we're looking at how many atoms of each element are present in the molecule. So we have one of these gray one. So oxygen, there's only one. So A cannot be the answer. The big black one was carbon. So it is carbon. So carbon, there are two of the big black one. So carbon, there are two. So D cannot be the answer. Hydrogen, the white color one. 1, 2, 3, 4, 5, 6. So there are 6 hydrogen. So make sure you know how to identify which atom is which based on how many covalent bond do they form by knowing your periodic table as part of atomic structure, and therefore by knowing how to count how many covalent bond, because you can count covalent bond. How many covalent bond you form will roughly tell you therefore the group number or the position of where they are in the periodic table. Question 3, so we have 4 different statements here. We're looking for the correct statement that describe the structure of copper. So copper is an element. If you know your periodic table, you will know that element 29 is copper. It has the symbol Cu, okay, not Co. Co is cobalt, okay. So Co is cobalt. Cobalt is also in the same row, okay, in the transition metal. Transition metal is that big block between group 2 and group 3 in the middle periodic table. So cobalt is in the same row. Cobalt is C, big C, small o, big C, small u, u for umbrella. That's the symbol for copper, okay. So we know it's a metal. It's a transition metal, by the way. Okay, so transition metal belongs to that. Everything in that middle block, they are called transition metal. And because you are metal, you have a giant metallic structure. And by definition, as required in the structure and bonding syllabus, I don't have it on top of my head, but you should know that this is definitely asked by Cambridge, that you will be able to define it, okay? Which means you should also be able to sketch a diagram, which you know you can put in the delocalized valence electron. So there's the delocalized valence electron. If you are able to sketch out things like this, that means you will have no problem putting it into words, because you know what it looks like. You can imagine it in your head because you have the knowledge, all right? So we have a lattice of cations or positive ions. So negative ions is out. Positive ion is correct, but you don't have it in a sea of proton. You have it in a sea of valence electrons, okay? So it's the valence electrons, they get delocalized in these to form this sea of delocalized valence electrons, where the positive cations kind of intercalate or kind of sit nicely in between, where they are attracted by metallic bond, which are strong metallic bond between the cations and the sea of delocalized valence electron. Question 4 is a very similar question, but what do we understand about the structure of ionic compound? Ionic compound, because when you have ionic bond, you can never have it in elements, you have it in compound, meaning you have 2 or more elements that are chemically combined in a fixed ratio. This is the basic definition of a compound as part of atomic structure under atoms, molecules, compound, mixture. All right, so what you have is alternating cations and anion. So you have alternating cations and anion. The ratio of which they are combined depends on the charges of the cation, the charges of the anion, because that is your lowest common multiple, okay? Your idea is to balance out the charge. How many ions of each charge must you have in order to get an overall uncharged compound? Ionic compound contain ions. Ions are charged, but ionic compound has no overall charge, okay? So we have a giant lattice, definitely. So it's not a giant molecular lattice. It's not a simple molecular lattice. You have ionic bond, okay, between metal cations and the non-metal anions. It's a giant ionic lattice, and you have it between oppositely charged ions. You should probably use a different color ink to make sure, you know, to drive home the message, I guess. This one is going to be giant metallic structure, which is the previous question, as you see on the right hand side. What I drew earlier for the earlier question was for giant metallic structure. Question 5, so we're looking at a statement about an ionic compound is not correct. Always circle underlined. Appreciate question by not just reading it 2 or 3 times, but by taking action. All right, this is all exam skills, and if you don't have very good exam skills back then, you should try and improve your exam skills. Otherwise, the same thing will repeat itself, and you will be reliving your worst history, your worst nightmare again and again and again. All right, so it conducts electricity when dissolved in water. That is true because you are going to get aqueous solution. When you dissolve ionic compound in water, you get aqueous solution. It will become a mixture. So when you dissolve in water, you are a mixture. You are not molten. Molten is liquid. This is aqueous solution, is a mixture, but you have free ions. Therefore, you can conduct electricity when it's aqueous, okay, or when it's molten, because your ions are free to move around. Okay, so this is a true statement, which means A is not the answer, because this is a true statement. B, it has a high melting point, high melting and boiling point due to strong ionic bonds between the oppositely charged ion. When they give you the options, they always didn't try to be as complete as possible. But then when you are writing as part of a structured paper, you always have to say due to strong electrostatic force attraction, which is actually the strong ionic bond between the oppositely charged ions, as that is definitely the definition for ionic bond as per the syllabus. So again, this is also a true statement. Now it has a regular lattice. Regular because they can also use the word ordered arrangement. Oppositely charged ion, that is correct. In a sea of electron is wrong, because that is actually giant metallic structure. So a lot of structure and bonding comes down to just 4 structure. The question is, are you able to differentiate and read the question and not get tricked now and again? All right, so ionic bonds are formed between metals and non-metallic elements, and that is correct. So you know the metals like to lose electron, and that electrons goes to the non-metal where they gain electrons. So you will show your dot and cross as ions, not sharing of electrons, but the ions that are formed as a result of transfer of electrons with the objective of getting to the fully filled outer shell. All right, so that is from atomic structure topic. Question 6, so you have covalent bonds. Covalent bonds are formed. So this is the process. Okay, so it involves sharing of electrons. It's the force of attraction between the bonding electrons and the 2 nuclei in between the 2 bonding electrons. The 2 nuclei contain protons that are positively charged, so they get attracted towards the bonding electrons. So what we have is when electrons are shared, not transferred, because that is to do with loss or gain of electrons, and that is to do with ionic bond. So most covalent compounds have very low electrical conductivity. So there's two there. So make sure you read the question carefully, because well, they don't have free electrons, they don't have free ions to conduct electricity, except for graphite. But graphite is giant molecular, and you do have a lot of covalent bonds within the structure of graphite, but you conduct electricity because each of the carbon atom in graphite only uses 3 out of 4 of its outer shell electrons for bonding. So each carbon has 1 free electron to conduct electricity, but there is something which is very special about graphite, and it certainly is not true for most covalent compounds which have poor or very low electrical conductivity. Question 7, so how many electrons are used to form covalent bonds? Okay, not how many electrons are there in the molecule, but how many electrons are used to form covalent bond. So CH3OH is in the syllabus under covalent structure and bonding. You're supposed to be able to draw the dot and cross for this as part of the practice in class, in lesson, and also as part of your homework, which you completed and submitted and get marked. All right, so this is actually drawn based on the display formula. Carbon form 4 bond, carbon form 4 covalent bond, because carbon is in group 4 outer shell electrons. To get to the fully filled outer shell, it needs to share 4 more. So carbon form 4 covalent bonds, because 4 plus another 4, that means it share with 4 other atoms. It will get 4 plus 4, which is 8 outer shell electrons. All right, so this oxygen is group 6. It's got 6 valence electron, so 6 plus 2 electrons that you share from the non-metal atoms. 6 plus 2 will give you 8. Hydrogen, only 1 electron in the outer shell, which is the first shell, so it share with 1 electron from oxygen, so it forms a single covalent bond. 1 plus 1 give you 2, and the reason is because hydrogen has its electron in the first shell. The noble gas helium only has 2 electrons in the outer shell, because that's the maximum that the first shell can accommodate, can allow the electrons to occupy, and these are all part of atomic structure, the previous topic. Okay, so we're looking at how many covalent bond. 1, 2, 3, 4, 5. So there are 5 covalent bond. You got to show all the covalent bonds, but in each covalent bond there are 2 electrons in 1 covalent bond. So altogether we're looking at 5 times 2, which is 10 electrons used to form the 5 covalent bonds. 2 electrons there, 4, 6, 8, 10 electrons in a molecule, because this is a simple molecule. It's a simple covalent molecule because it has a simple molecular structure. Question 8. So you have a covalent molecule, which each of these is a covalent molecule. As part of your case study, everything is from the syllabus, nothing is from outside the syllabus, which you revise completely based on the syllabus, which you were taught completely based on the syllabus, which your textbook shows you completely based on the syllabus, right? So if I just draw for each and every one of these, which you'll be able to draw because they were part of your exercise. Nitrogen is in group 5. It's got 5 outer shell electrons. It uses 1, 2, 3 for bonding. It still has 2 more electrons. Okay, HCl. So chlorine is in group 7. It only uses 1 out of 7 for bonding. Hydrogen uses the only 1 electron it has for bonding. So methane, CH4, it uses all 4 of its outer shell for bonding, and these are hydrogen, so they use their only electrons for forming covalent bonds already. Water, H2O, so these formulas as well as how they look like are all part of the syllabus, something to be covered as your case study. Oxygen is in group 6, so it's got 6 outer shell electrons. It forms 1 and 2, so it shares 2 electrons from 2 of the hydrogen, so it uses 2 electrons because oxygen share 1 there, hydrogen share 1, hydrogen share 1. So oxygen shares 2, 1, 2 out of 6. You still have 4 more because oxygen is in group 6. Group number tells you how many outer shell electrons you have. These are all from structure and bonding. Okay, so a covalent molecule contains a total of 4 shared electrons. Be careful, the question says 4 shared electrons. It does not say 4 shared pair of electrons. A pair is 2, but it does not say that it's a pair. It just says it's 4 shared electrons. So this is 2, 4, 6. This is actually 6 shared electrons. All right, so 1 there. So there's 2 shared electrons, and here you have 2, 4, 6, 8. So you got 8 shared electrons, and here you have 1 and 2. So you got 4 shared electrons. So we're looking at H2O. The question can change suddenly to have a total of 4 pair of shared electron. 4 pair of shared electron. It would be this, because 4 pair would mean 4 pair of shared electrons would mean 4 times 2, which is 8 shared electron, which will make me 10 the answer if there is a pair in the question. So be very careful when reading question, yeah. Number 9, so, they are asking on methane. Methane is CH4. As you could see, the structure is here, so I don't really need to redraw it again. So it's between carbon and hydrogen, so it's between non-metal and non-metal. So both of these are non-metal and non-metal. And as part of your case studies, you know that they don't do transfer of electrons from one atom to the other because that is to do with ionic bonding. There's the process for forming ionic bond, just to do with sharing. These are covalent bonds, so both atoms will gain a noble gas electronic structure, of which you can see the carbon, 4 outer shell electrons, gain 1, 2, 3, 4, so 4 plus 4 is 8 electrons. in the outer shell of carbon. That is for neon. That is neon's electronic configuration. Each of the hydrogen is happy because one outer shell electrons for each of the hydrogen, plus one more, one from this carbon. This one get one from this carbon, this one get one from this carbon, this one get one from this carbon. So each of these hydrogen will have helium's electronic configuration, and therefore they both get a noble gas electronic configuration. That's the whole idea for forming the covalent bond in the first place. Okay, they do not have same number of electrons in the outer shell, because you got to think about helium versus neon. Okay. Number 10, which of the following exists in the solid state as a giant covalent lattice? Giant covalent lattice, the other name is called giant molecular lattice. So giant molecular lattice. Ice is H2O, is simple molecule. Even though it's ice, you still have a lot of molecules packed together. Still as individual molecules, they are close together, they are tightly packed. Okay, so that's a method to describe the structure of solid, but it's a simple molecule to begin with. It's not going to be giant molecular. Iodine is the same thing. The iodine molecules remain as molecules because you are just making the molecules stick very close together. They are very tightly packed. All right. Tin for chloride. Tin is considered a metal. Tin is metal. Cl is non-metal. In fact, tin and chlorine as an element is this diatomic molecule. So you have giant ionic structure. Okay, so you can think of it as being a giant ionic structure. All right, and this is silicon 4 oxide, so this is SiO2. Sometimes it's given as sand. It's a component of white sand. So you should be able to sketch it out. Oxygen, oxygen. Each silicon is bonded to 4 oxygen. Silicon is below carbon in period 3 in group 4. 4 outer shell electrons. 4 plus 4 give you 8. Each oxygen will form 2 covalent bonds. Because oxygen is group 6, it's got 6 outer shell electrons. It forms 2 covalent bond. The thing is, it will form bonds to silicon. And each silicon is bonded to 4 other oxygen again. So I already shown 1. So I just need to show the branching. Okay, the branching to 3 other. But I do not have to go further. If I can sketch this, it means it branch out further to oxygen, because I've shown the central structure like that already. If this is a structured question where they ask me to sketch. Alright. Question 11. So circles of different sizes represent atoms of different elements. Okay. You're looking for hydrogen chloride gas. Hydrogen chloride was part of the case study in diffusion. So you have hydrogen chloride and ammonia to give you the steamy white film, the white solid that forms closer to the HClN, because NH3 is lighter, which you can do in terms of molecular masses. MR calculation from topic 1, that's a meta explanation, and you're supposed to include all the explanation, and you know about where they will meet and give you the white solid HCl and NH3. Of course, you know all that as part of your case study. So now we have HCl gas. They are between non-metal and non-metal. Hydrogen is a non-metal, exists as H2. Cl2 is a non-metal, exists as Cl2. Both are gases at room temperature and pressure. Both are diatomic molecules. They are gases at 25 degrees Celsius, which is room temperature. When they react together, they're going to give you this covalent compound as a simple molecule. So it's a simple covalent molecule. It has a simple molecular structure. Okay. So that exists as molecule. This is called a diatomic molecule. This is also diatomic molecule because each of these contain 2 atoms. But these are elements. These are compound because they contain 2 different elements bonded together chemically bonded together in a fixed ratio. These are all atoms. So you can cross out B. I can cross out D because these are atoms. And in terms of C and A, we know the formula is going to be HCl because hydrogen forms single covalent bond. Chlorine is in group 7. It forms a single covalent bond to the hydrogen. It's not going to be like this. This represents water. H H2O. 2 hydrogen, 1 oxygen. Here is 1 hydrogen, the smaller one, and 1 CO, which is the bigger one. Bigger because chlorine is a third period element, hydrogen is a first period element, so filling up the first shell only, filling up to the third shell, including the first, second, and then the third shell. Atomic structure, electronic configuration. Question 12. So for which substance is the type of bonding not correct? Not correct. Okay, so read very carefully. So chlorine exists as Cl2, which is chlorine. 7 outer shell electrons, share 1 with each other. 7 plus 1 equal to 8 outer shell electrons. Each chlorine atom become happy. So this one is correct. But they're asking for not correct, so always read the question very, very carefully. Potassium bromide. Potassium is group 1. So K plus group 1, Br minus group 7. So this is metal and non-metal. And you should realize that there is a transfer of electrons from the potassium, which lost the 1 outer shell electrons, to the bromine atom, which gained the electrons to give you the bromide ion. Metal and non-metal give you ionic compounds, so that is again correct. Sodium is a metal, so this is a metal, and that is once again correct. Correct, meaning to say that is a correct statement, so it cannot be the answer. Sodium chloride. Sodium is group 1, metal. Chlorine. Okay, so chloride comes from chlorine, so there is a group 17, Cl2. That is a molecule, but the molecule, you can break the bond and give you the chlorine atom. Then the chlorine atom will be 1 electron short of a fully filled outer shell, and you are bonding with sodium, which is more than happy to give away the 1 electron, to transfer the 1 electrons onto the chlorine atom. Okay, after you break this bond, you get chlorine atom. Gain 1 electron from sodium, you get chloride. Okay, so Cl2 going to the chlorine atom. So this is a molecule, this is the atom, and then this is the ion. So you learn about molecule, you learn about atom, you learn about the ions. These are the process involved, going from what it exists as at room temperature and pressure, and how it will react in the presence of sodium in terms of forming the ions via the atoms. Okay, so it's definitely not covalent, okay, because it's not sharing of electrons, so this is covalent there. So D must be the answer because it's looking for not correct. Question 13, so a bit of atomic structure here. Element X has 6 electrons in its outer shell. If you have 6 electrons in outer shells, that makes you a group 6 element. So Roman numeral Vi. Don't think my handwriting can get any better. How could the element react? When you gain 2 electrons, you do not form a positive ions, you form a negative ion. So losing 6 electrons, when you lose electrons, then you will form cations. Okay, so that is again not negative. Cations is positive ions. This is stated very clearly in the beginning of ionic bonding. Describe the formation of cations and anions in the syllabus. All right, so instead of just gaining or losing, all right, you could also share electrons. So group 6, such as oxygen with itself or with other non-metal, you can just share electrons and form covalent bond. So you can form up to 2 covalent bonds, but not 4 covalent bonds, because you're looking at group 6 plus 2. You have 6 outer shell electrons. How many more do you need to share in order to get up to a fully filled outer shell? Okay. Number 14, which one will react together to form an ionic compound? You're looking at a metal and a non-metal bonding together. So this is the outer shell configuration. So this is group 4, 4, not 6. So group 4, IV. This is first shell, second shell. First shell can only accommodate 2 electrons. This one has got 3 shells. Remember, period number tells you up until what shell are occupied with electron. First shell has 2 electrons. Second shell has 8 electrons. Third shell, which is the outermost shell, has 1 electron. So this is a group 1, whereas this one is group 8. This one is group 7. Okay, so now we're looking at metal and non-metal. If we have to categorize this, we can think the group 1 definitely metal, group 7 definitely non-metal. Okay, so oh, hang on, group 8 is not non-metal. Group 8 is noble gases. This is noble gases, so they are unreactive because they have a fully filled outer shell already. So this one is a group 7, which no need for me to write again. That one is definitely a non-metal. So W is group 4, is also a non-metal, but what is very obvious for ionic bond formation is definitely between a metal and a non-metal. So we are looking for the very obvious thing first before we look for the less obvious thing. Okay. Question 15, we are looking for pairs of electron share between atoms. So we are looking at covalent, share. Yep, okay. So we're looking at covalent bond formation. Covalent bond is between non-metal and non-metal atoms, so between non-metals. When you have sodium chloride, I hope at this stage you can see that metal sodium, non-metal chlorine, well, just like this, group 1 sodium, group 7 chlorine. Okay, so Na plus Cl minus, that one is ionic bond, so it involves transfer of electron from the sodium atom to the chlorine atom. Okay, so one is definitely wrong. So one is definitely wrong, one is definitely wrong, one is definitely wrong, which means without even checking, there's only one answer. All right. Hang on, let me think. Yeah, because even though you know methane is definitely correct, like that is CH4, we talked about it earlier. You can get CH4 as part of your case study. This is display formula, which you can translate easily into dot and cross, because you can count the bonding electrons very easily using your knowledge of atomic structure, previous topic. Okay, the question really is lead bromide. How can I be sure that that is definitely wrong? Well, 2 is definitely correct. Okay, and then 3 is also definitely wrong because 3 is together with where 1 is present, so by elimination only 2 is correct. Okay, but when you think about it, lead is a metal. Lead is in group 4, just all the way below carbon, silicon, germanium, tin, and then lead. Pb is a metal. So the metallic character of group 14 elements, it become more metallic going down the group. Carbon, graphite, carbon, diamond, they are non-metals, but going down the group, lead is a metal, tin is a metal. Okay, and then you have bromine, which forms the bromide, Br minus. That means this one is going to be ionic compound. Okay, number 16, we're looking at the simple covalent molecules. So simple covalent molecules do not conduct electricity when solid, when molten. Okay, they do not conduct electricity when solid or when molten because they exist as molecule. Okay, no free electrons or ions. In fact, no free electron is fine because we don't talk about ions to conduct electricity. No free electrons to conduct electricity, so that one there and that one there. Okay, so we're looking at both of them. Both of them do not conduct electricity either when solid or molten, so both of them do not conduct electricity when solid or when molten, but they are very volatile. Now this word volatile, a volatile person gets angry easily. Okay, so volatile means boil easily. If you boil easily, that means low boiling point. Okay, so this is an English word, volatile. Volatile means how easy is it boil. Okay, how volatility is to do with how easy you boil. Okay, volatile means you boil easily. If you boil easily, you have low boiling point. That means it's a property of simple structure, simple molecular structure. Number 17, so you have a metallic element, so you have a giant metallic structure, but it seems like the question is about a lot of properties and you're looking for which one is correct. Okay, malleable Malleable means you can hammer it into thin sheets. It's because of the layered structure. So the layer of cations can slide over each layer. So they are able to move. It's not cannot move. They can slide. In a fixed position, not really, no. Well, you know the ions can move, right? Including the electrons can move. That's why the electrons move. You can conduct electricity. But even though when it's solid, even though the layers of ions are in fixed positions, but they can slide. So maybe I was wrong. They are in a fixed position in a layer structure, but they can slide. Okay, so they are able to move, and that's why application of force, you can make the layers slide off each other, and therefore it's malleable. But this is correct, but this is wrong. So this is wrong. Okay. Structure of copper consists of negative ions. You cannot have negative ions not for elements. Remember, metals are elements. Okay, elements do not have giant ionic structure. Okay, never ever ionic bond. Okay, if you never ever have ionic bond in elements which are metals, then how can you have negative ions? Okay, so 1 and 2 is wrong. 1 and 2 is wrong. 2 is wrong. 2 is wrong. There's only one answer. Well, let me just go through the answer anyway. So copper conducts electricity because electrons can move through the metal. Remember, the positive ions stay where they are, but the electrons are the one that move. So 3 is definitely correct. Alright, so electrons hold copper ions together. Electrons hold copper ions together. So earlier we talked about the giant metallic structure, which you should be able to sketch easily and label. Okay, so my cations should be of similar sizes. So these are my cations, my metal cations, and these are my delocalized valence electrons. The attraction between the cations and the delocalized valence electrons, the electrostatic force attraction, okay, that is defined as metallic bond. Each chemical bond is to do with electrostatic force attraction between something positive and something negative. Okay, question 18. So we have electronic structure of 2 atoms. Here you have 1 2 3 4 5 6 7. So X is group 7 element because it's got 7 outer shell electrons. Y has 1 2 3 4 5 1 2 3 4 5 6. Okay, so it's got 6 outer shell electrons, so it's in group 6. So we're looking at what kind of bonding can you have between a group 6 and a group 7 elements when they combine together. So we can imagine these 7 outer shell electrons, 6 outer shell electrons, they are towards the right side of periodic table. So they are both non-metals, and therefore ionic structure is definitely a no-no, because none of them like to lose 6 or 7 outer shell electrons. Doesn't make sense. They might as well just do sharing of electrons to get up to noble gas configuration. This is 7 outer shell electron. I just need 1 more to share. Okay, guess what? I can share with these, okay, and I can share with these, but which means I need 2 of the X. So 1 X can go here. You can share with this and this, but this one will be short because 1 2 3 4 5 6. So I need another one of this to share with this. So I will get X2Y. So meaning to say I will get a single covalent bond YX. So this one is a group 6. 6 outer shell electrons plus 1 plus 2. 6 plus 2 is 8. X is 7 outer shell electrons from 1 covalent bond, because 7 plus 1 from the Y, 7 outer shell electrons for X from the atomic structure, the last topic. Gain 1 electrons, well, not gain, sorry, share 1 electron with Y. So 7 plus 1 give you 8. So the formula is going to be 2 of the X and 1 of the Y. Very quickly, covalent X2Y. Question 19. So we're looking at silicon 4 oxide. So the structure, as you know, you should be able to sketch very quickly. I mentioned it in an earlier question, so I don't want to mention it again, because otherwise I'm repeating the same thing again and again. But I need to show the silicon bonded to 4 other oxygen, so I just show it as branching like this. So it's a giant molecular structure. So it has a giant structure similar to that of diamond. I agree that it has a giant structure. but it's not really similar to that of diamond. But when I'm faced with situation like this, then this question is asking me on what is not correct. Careful, yeah, not correct, not correct. So always read very carefully. I can't say this is very confusing, right? This is true, but in diamond it's slightly different. I hope you remember in diamond, each carbon is bonded to 4 other carbon, and then each carbon is also bonded to 4 other carbon. So kind of similar, but not exactly the same, because here the oxygen is only bonded to silicon. So maybe I go through the rest of the options and see whether it makes sense or not, okay? High melting point, because of the giant molecular structure, you need to break the many strong covalent bond. Many strong covalent bonds between the atoms. So this one, it says between the molecules. That is definitely wrong. Okay, I got my answer there. It's the strong covalent bond between the atoms. Okay, so a lot of it comes down to English and being careful what you are reading. There are strong covalent bonds between silicon and oxygen. That is true, and because you need to break so many of these strong covalent bonds, that's why it has very high melting and boiling point. No free electron is true, because silicon uses all 4 of its outer shell for forming covalent bond. No free electrons at all in the giant molecular structure of SiO2, component of white sand, so they do not conduct electricity. So this is also true. This is definitely wrong, okay? And which means A, they consider as correct, because I guess there's similarity in the structure, but it's not exactly the same, yeah, it's just similar. But whenever you're faced with a situation like this, always go through the other options and determine which one is definitely that you can definitely pinpoint down to what the question want, or at least you'll be able to eliminate the impossible one, and you'll have better chances, okay? Question 20, you just need to read what is carbon, what is chlorine, what is hydrogen. So carbon, there are 2 of the black one. Carbon form 4 bond, 1, 2, 3, 4. Okay, so there's C2. Hydrogen is the white color one. Hydrogen forms single covalent bond, so there are 3 hydrogen. And chlorine is the dark gray one. Chlorine is group 7 element. So 7 outer shell electrons, it forms single covalent bond. 7 plus 1 equal to 8. Fully filled outer shell for chlorine. Okay, so there's only 1 chlorine there. 1 chlorine, so that's why I don't write the 1 there. C2H3Cl. C2, so this is C1. This is C1. This is C2, H3Cl. So here there's only 1 hydrogen there. That is wrong, yeah? Okay. Question 21. So potassium bromide. So potassium is K. Bromine give you the bromide ion, and the fact that you have bromide and you have a metal, group 1 metal, group 7 non-metal, that's why you get this giant ionic structure that forms this ionic bond between the oppositely charged ions. Methanol is your case study, and they are given you're given the name and the structure as part of your exercise on dot and cross of covalent compounds, also stated very clearly in the topic 3 syllabus. Alright, so this is simple molecular structure. So you are just breaking the weak intermolecular forces between the methanol molecules when you melt or when you boil it. This one has a giant ionic structure, so you will need to break the strong ionic bond between the oppositely charged ions when you melt or when you boil potassium bromide. So the one with the higher melting point cannot be the simple molecular structure. It has to be the giant ionic structure. It has to do with the force attraction, which is the ionic bond between the oppositely charged ion, is definitely greater than the weak intermolecular forces between the molecules. To melt or to boil simple molecular structure, you would have to just break the weak intermolecular forces between the molecules. You do not touch the covalent bond because you have a simple molecular structure. Okay, so the ionic bond is a stronger bond, require a lot more energy to break than the weak intermolecular forces between the methanol molecules. Okay, so here this is the other way around, and that is not true at all. 22, so in these molecules CH4, which you'll be able to draw the display formula very quickly, because that is what you're supposed to know from the syllabus. All right, which atom use all of their outer shell electrons in bonding? Okay, Well, I can tell you which atoms. This one use all the outer shell for bonding because the carbon has 4 outer shell electrons. So the carbon uses 1, 2, 3, 4 for bonding. The hydrogen has 1 outer shell electrons. They use their only outer shell electrons for bonding. Therefore, it's carbon and hydrogen. Okay. Whereas this hydrogen, yes, but then Cl is in group 7. So it still has 6 more that you haven't completely used for bonding. The hydrogen, yes, but the oxygen is in group 6. I only use 1 and 2 because they are single covalent bond. So 1 electron, 1 cross there, 1 dot there, 1 cross there, 1 dot there. So it only uses 2 out of 6 outer shell electrons for bonding. So not the oxygen, not the chlorine, but the hydrogen and the carbon uses all the outer shell's electron for bonding there. Gotta read the question carefully. Question 23, so we have rescuers drilling through fallen rock. So you need to drill through rock, and the drill needs lubricating from time to time, so be very careful what they are saying. We use the diamond for the drill tip, okay, the drilling tip, which is the same as, so this is called the drilling tip. Sometimes we call them the drilling bit. Okay, they are used in mining or petroleum industry where you need to dig into underground very hard rock, and that is because diamond is very hard. It's one of the hardest substance of all. It's to do with the 3-dimensional giant lattice structure, which means that it's very rigid, and these are all in the notes. And there has been a couple of questions from your previous work as you're leading up to this test, which you have done the corrections on. That's why you have revised completely before you actually did this test. All right, so 2 is definitely correct. And even though diamond does not conduct electricity, so this is a correct statement, but not relevant. Okay, irrelevant, because you don't conduct, but that's not why you use it for drilling tip. So be very careful when you read question. Okay, so graphite is used as a lubricant. Yes, this is again a correct statement, but that is not why you use it as a lubricant. You use it as a lubricant because of the layered structure, the layered 2-dimensional structure of graphite. Means that you are only breaking the wick, easily slide over the layer. Okay, so layers can slide easily, and because only breaks, why did that keep on happening? Only breaks weak van der Waals. Remember, you have van der Waals forces between the layers, and that's all you break when you slide over each other. Okay, so this is about what is relevant, what is or what are relevant in the context of the question. All right, so I better write that clearer. What is or what are relevant to what they're asking. So 2 and 4 must be the context, there must be the concept required in the context of this question. Question 24, so we have some symbols. These are not, they already specified for you, the symbol for the elements. So which one forms an ionic compound with element P? So P is here, so P is group 1, so that is going to be metal. So you're looking for metal on the left hand side. P, Q and T are metal. You're looking for non-metal. This thing is group 8, so this thing is a noble gas. Noble gas are unreactive because it's got a fully filled outer shell already, so it does not want to gain, it does not want to lose, it does not want to share electrons. We are looking at the non-metal here, which will be R, because R is in group 7. 7 outer shell electrons. It still like to either gain one, okay, with a metal that would like to lose electrons. So R will be our answer, which means B there. Question 25, hydrogen chloride is your case study again and again. It's a simple covalent molecule, which unfortunately, if you don't get your case study correct, you might make a lot of mistake in this test. Okay, potassium is a group 1 metal, chlorine is a group 7. Okay, so think about the group 1 metal, potassium is there, chlorine will be third period, group 7. So the metal like to lose electrons, the non-metal likes to gain electrons. So you have metal and the non-metal. Eventually when you become expert, you will know it's K plus, Cl minus. So it's KCl. So it's a giant ionic structure. So which statement about them is correct? That's what they want. Okay, hydrogen chloride is covalent, that one is ionic. Well, there's the answer. Okay, so hydrogen chloride is not ionic. Look at this, they do not conduct when it's solid, they do not conduct when it's liquid, but HCl molecule can dissolve in water to give you an aqueous solution of hydrochloric acid, which can conduct electricity because of the presence of ions, where this covalent bond can break in the presence of water. They are both covalent compounds? Clearly not. They are both ionic compounds? Clearly not. All right. (26) So structure and bonding again. So we have sodium chloride, which by this stage you know it is ionic, as part of a case study. Sulfur dichloride. Sulfur is group 6, chlorine is group 7. Sulfur dichloride, SCl2. When you think about this, I hope you remember what you did in the previous question, which, assuming you got it correct, very similar to this. Group 6, group 7. The purpose to get to fully fill outer shell. So I will have one of the group 6 forming single covalent bonds, therefore 2 of the other one. So this will be SCl, Cl, SCl2. Okay. So coming back, a lot of questions are related to one another. The question is whether you will think about them like that or not. Okay. Group 6, group 7. Group 7 form one covalent bond because 7 outer shell electron share one with the group 6. Another group 7 element share one electron with the group 6. 7 plus 1, 7 plus 1. This is group 6, 6 outer shell electron, 6 plus 1 plus another one. All of them are happy with fully filled outer shell. Anyway, so that's why it says simple molecular. This is low melting point. You can also think of them as low boiling point. This one is very high melting point. So why in the world does sulfur dichloride have a lower melting point? Structure and what are you breaking? Structure and what are you breaking? The covalent bond are weaker. Well, that is a wrong statement because we do not break covalent bond. Why? Because these are simple compounds, simple molecular structure. It gives you for free. You don't even have to think about it. But given the low melting point, that should tell you, okay, we do not break covalent bond for simple covalent molecules. And that is something that we reiterate again and again and again until you get sick of it, until you never make that mistake ever again. This is to do with covalent bonds again, so this cannot be. Alright, so we're talking about the attractive force between the molecules in SCl2. So between the molecules, you have weak intermolecular forces, and that is what you break between simple molecules. That's why you only need very little amount of energy. That's why it's very low melting and boiling point. They are a lot weaker. Okay, the intermolecular forces, that one is called intermolecular forces. Oops, sorry. That is called intermolecular forces of attraction. So that means it's forces of attractions between the molecules. Inter means between, intermolecular, between the molecules. So blah 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 blah. So that thing is weaker than the attractive forces between molecules in sodium chloride. This one, it says weaker than the ionic bond in sodium chloride. I'll tell you something is wrong here. Between molecules in sodium chloride, that is the wrong thing. You have Na plus and Cl minus. This is not a molecule. You should know that you have a giant ionic lattice as stated in the syllabus under ionic bonding. Candidates should be able to state a giant structure. Okay, array of alternating cations and anion. okay, repeated array of alternating cations and anion in this giant ionic lattice, which consists of regularly ordered or very regularly arranged alternating cations and anions. All right, so it's not a single molecule, and it's definitely just the ionic bonds which give you the ionic structure, giant ionic structure. All right, so the answer must be C there before I forget. Question 27. So these are physical properties. We are looking for giant covalent structure, the other name of which is called giant molecular structure. So as with any giant structure, we are not concerned with law, melting and boiling point. So these are law, melting point or boiling point. Giant structure does not have this kind of negative melting point or boiling point in degrees Celsius. So between C and D, the melting point and boiling point looks all right. So the next thing we look for is electrical conductivity. Okay, so giant covalent structure, giant molecular structure, or even simple molecular structures, they do not dissolve in aqueous solution typically. But when you think about solid and liquid, they do not conduct, okay, unless you are graphite, But since we say A and B are already wrong, so we just look at C and D. This is solid. If you have graphite, if graphite, it will be good, but none of these are graphite, but they're still giant molecular structure. When you have a molecular structure, whether it's simple or giant, except for graphite, most molecular structures, they will have poor electrical conductivity when solid. So that is correct and correct. When it's liquid is good, that is not correct. This is most likely for ionic compound, because ionic compound can conduct when it's molten. Then the liquid ions can slide past each other. They become mobile. They become free to move in the liquid state. That's why liquid ionic compound can conduct electricity, but not when solid. Okay, and also this is good. So this thing, and this thing refers to ionic compound, which also have giant ionic structures, so very high melting and boiling point, do not conduct when solid, but conduct when aqueous in water, or liquid when they are molten. Giant molecular structure, we're looking at something which do not conduct, whether it's solid or liquid, and they do not dissolve in aqueous solution as well. So D must be what we are looking for. 28, you have a gas that has this molecular formula. So there is one nitrogen, one oxygen, and one Cl. This is atoms, whereas you are looking for molecule. Okay, so they are not combined together. They are combined together, nitrogen, oxygen, and chlorine. Okay, so here what you have is they are not combined together. How you can see if I use a different color, they are not combined together. So here they are not combined together. Not combined together. So C is also incorrect. So now between B and D, how do I decide? Well, I hope you can see this one is a straight molecule, 1, 2, 3. This is also 1, 2, 3, but all of these are the same. All are the same molecule, exactly the same, because all of them are bent slightly, like slightly curved. They've got a gray color one in between. Here this one has got black in between. This has got white in between. White in between, black in between, black in between. So these are not all the same. Not all are the same molecule, because some of them are not curved or are not bent. Some of them are linear, straight. But this question says pure. Pure means it's not a mixture. Not a mixture. Not a mixture. Mixture consists of two or more substances mixed together. So we're looking at B as the only correct answer here. 29. So we have X, Y, and Z to have these physical properties. So first of all, you look at this law, melting and boiling point. I am very tempted to think this is simple molecular structure. But when you think about this, 98 is pretty low as well. So how in the world do I decide? Anyway, let me have a look at this again. If I look at X, there's bromine and iodine. If you know your group 7 chemistry, fluorine, chlorine, bromine, iodine. I talked about this in the extra class, and also you were supposed to have watched the checkpoint question tutorial video or the work solution as a PDF, because you were supposed to have finished the checkpoint on your own during the holiday and revise completely before you actually started the work, before you actually revised for this test. You're supposed to have gone through all of that for correction. So this is a gas. This is a gas at 25 degrees Celsius. All right. So this is what we call room temperature. You're supposed to have done all that corrections, and all these were discussed as part of the questions in checkpoint. All right. Bromine is one of two liquids in the whole periodic table. The other one is liquid mercury. Liquid mercury is a liquid metal. Mercury is a liquid metal. Bromine is a liquid non-metal. Okay, so there are only two liquids in the whole periodic table. One is liquid bromine, is a non-metal. The other one is liquid mercury, which is a liquid metal. Sodium, not sodium. Iodine is a gray solid. It's a gray color solid at room temperature and pressure. Okay, so this is -7 and 59. If you have temperature, very simple diagram scale like this. This is melting point, this is boiling point, 59, and I have around 25 degrees Celsius there. So between melting point and boiling point, it must be a liquid. Before your melting point, it must be a solid. After your boiling point, it must be a gas. So at 25 degrees Celsius, you're looking at something which is a liquid. So X is a liquid. X is a liquid. At 25 degrees Celsius, iodine is a solid. Okay, a solid at 25 degrees Celsius, which means X cannot be iodine. Okay, case studies. All right, the more you do, the better you get at these, because the more knowledge you have. All these were in the checkpoint questions. They are not like something new, because you would have done checkpoint. If 1, you have done all of them. If 2, you have attended the extra classes. If 3, you have done the corrections on your own as well, even though you haven't attended the classes. And 4, you have done the corrections. Well, I think I said that as 3. Okay, so I'll move on. And then for Y we have something which has low melting point but high boiling point. So this is a strange one, and this one is lighter than water. Okay, so Y is lighter than water. Water has a density mass over volume is around 1.00 gram per cm cube. In maths you will learn gram per cm cube. It's the same as gram cm minus 3. This is maths. It's come under indices. Okay, this is in maths D, not additional maths, in the normal maths that normal people do. Okay, so this is very clearly sodium. It cannot be silicon or magnesium or whatever. It has to be sodium. Okay, because aluminium is denser than water. Aluminium does not float on water. Sodium floats on water because sodium is lighter than water. So a bit of case study there. 29 must be B. Alright, and then this is just a metal, giant metallic structure, high melting and boiling point. Sodium has a very strange and funny melting point, but we know sodium is lighter than water, and this correlates well with something you will learn later on as part of metal case study in O-level or IGCSE metals, chemistry of metals. Question 3, we're looking for something which is an ionic compound, so something which has giant ionic structure, and you will be thinking about properties, properties such as volatility. Volatility is to do with how easy to boil. Remember, a volatile person boils easily, gets angry easily. So high volatility means boils easily. If you boil easily, your boiling point will be low boiling point, you boil easily. That means high volatility. A bit of English there. All right, ionic compound has a giant ionic structure, so you will have high melting and boiling point. Okay, you will have high melting point and also boiling point. If you have high boiling point, you do not boil easily. If you do not boil easily, you will have low volatility. Therefore, low volatility. So a lot of it comes down to the English. Do you understand what volatile means? All right. So low volatility, not high. Conductivity, when it's molten, is a giant ionic structure. When molten means what is it? A solid to liquid. So you have liquid ions that can slide past each other. So you have mobile, you are free to move. Therefore, you will conduct when it's molten. So which means we got our answer without even looking at the last one. But of course, you know ionic compound. Most ionic compound are soluble in water, even though these are not stated as part of your syllabus. But I can tell you most ionic compounds are soluble in water. We talked very briefly during the school holidays classes that there's something called ion dipole bond if you are interested to find out. But I can tell you that most ionic compounds are soluble in water. You probably don't need this at all at O-level or IGCSE because there's essentially A-level concept. The next bit, materials can be classified by their chemical structures. So there are only 4 structures, as you know: giant metallic, giant ionic, simple molecular, and giant molecular. So which one has a simple molecular structure? Well, first of all, I would say these two are high, very high melting point and boiling point. We are looking at giant structure. If we are looking at giant structures, we are not looking for simple. Alright, so why in the world did I not consider this high? Because water also boils. H2O boils at 100 degrees Celsius, consider low. So in general rule of thumb, anything below 300 degrees Celsius or 400 degrees Celsius is still considered low. Okay, so between A and B, how do I decide whether it's a simple molecule? Well, they will be insoluble when you add water, but sometimes they can react. Okay, but here, electrical conductivity always poor or good when solid. Good when solid, this is important. Good when solid is going to tell you that it's metals. Or could it be graphite? But graphite is giant molecular, and graphite will have very, very high melting point, boiling point. Look at this melting point here. It cannot be graphite. It must just be different metal, because only metals can conduct when solid, as well as graphite, despite it being a giant molecular structure, because graphite has that layered structure where well, not because of layered structure, but because each carbon in graphite only uses 3 out of the 4 valence electrons to form covalent bond to the 3 other carbon. So you got 1 free electron on each carbon to conduct electricity. These are commonly asked in structured questions, as well as part of the explanation required by the syllabus. Describe and explain the electrical conductivity of graphite, okay, as stated in the syllabus. All right, so good when solid is not true for simple molecular structure. All right, so I have to be looking at B for the only sensible answer, despite B not having the lowest melting point, but is also considering other properties. And most of the time, a lot of students will just choose the lowest melting point without thinking about the other factors, without thinking about the other information given in the question. Okay, so reading is key. In using all the information is key. Convincing yourself that is the best answer is also key for MCQ. If you are easily tricked, you are easily tricked. Question 32 is another one of those structure and bonding table kind of question. So looking at these, again, you see that these are considered low and they do not conduct when liquid. So that means not metal. Therefore, this must be simple molecular. So we are looking at Y being simple molecular. Therefore, I can cross out B and D. Okay, so how about looking at X and C? When it's liquid, it conducts. So giant molecule do not conduct when it's solid or liquid or gas, except for graphite, which in your case study, graphite conducts for the reason I just stated many times before, as well as in the previous question, like literally minutes ago. So in the liquid state, when it conducts, we're looking at ionic and not giant molecular in general, okay, in general. But let me go through the other option. This is giant molecular, very high melting and boiling point, does not conduct in general the giant molecular structure, except for graphite, of course, which also conduct in the solid state. And even when you go to liquid state, I don't know, I mean, it takes like 4,000 plus degrees Celsius for the graphite to go into the liquid state. But even when you go into the liquid state, the carbon atoms might no longer be bonded to the other carbon atoms, so it might not conduct anymore in the liquid state if you can, well, you know, if you can melt graphite essentially when you think about the structure, okay, because you are breaking many strong covalent bonds when you go from solid graphite to liquid graphite because of the giant molecular structure. Question 33. So which one of the following is an ionic solid? So something that has very high melting and boiling point. I can cross out A straight away because that is low melting point and also boiling point. We know that ionic compounds do not conduct when it's solid, so this is good. So this is cannot be. Ionic compounds, no free ions in solid state. They can only vibrate about fixed position, right? So B is also out. So now I need to look at C and D, which means molten. Molten means liquid. Aqueous means in water. Okay, so most ionic compounds are soluble in water, and also of course ionic compound, when they are liquid, the liquid ions are free to move because the liquid particles, liquid ions, can slide past each other. So poor electrical conductivity when it's molten does not tell you it's ionic solid. In fact, from there already I can tell C must be the answer. All right, 34, we are looking for the structure of metallic copper. Very generous of them to even tell you it's metallic. So you have a giant metallic structure, which of course you should be able to sketch very easily, and also label, because it's easy to sketch. But without labels, you are not saying anything at all without labels, okay? So these are delocalized valence electrons. These are cations. The force of attraction, the electrostatic force attraction between the oppositely charged species, I don't say oppositely charged ions, I say oppositely charged species, between the positively charged cations and the negatively charged delocalized valence electrons. So you have a lattice of ions. They never say it's negative, they only say a lattice of ions, which you know is correct. Positive ion is ion, negative ion is ion. They do not specify, they just say it's ions, so it is correct. Delocalized electrons, of course, delocalized valence electron. And you never ever have ionic bond because this is element. Okay, so 1 and 2 is correct. There's B there. 35, you have the lead in the pencil, but it's not made of lead because lead is actually toxic. So you do not want lead for your writing and your pencil. Okay, lead is toxic to you. Okay, so it's a mixture of graphite and clay. When the percentage of graphite is increased, they can slide across the paper more easily, so more lubricating. Okay, so it's slippery. Slippery meaning it's lubricating because graphite is a lubricant. The two-dimensional structure, layered. Oh, my handwriting is terrible, but it goes to show the two-dimensional layer structure of graphite. When you act as a lubricant, you are just sliding the layers past each other. Therefore, you're just breaking weak intermolecular force. That is, breaking the weak van der Waals forces between the layers. That's why they are very easily slide past each other. Therefore, they're very good lubricant because it's very easy to break that weak intermolecular force, that weak van der Waals forces. Okay, between the layers. 36 more of these kind of questions. This one is low. We are very low. We are looking at what are we looking at? We're looking at simple molecular. The question is, which one? You see R, all of these are simple molecular, by the way. In case you should know NH3, you should know HCl, hydrogen chloride, but you might not know C2H5Br. Br is in group 7. Carbon form 4 bond, and you have hydrogen forming 1 bond. So you know, it is something new, but it is something from your checkpoint also. So it's not like you've never seen it before, and it's not like you're not able to do it, because ideally speaking, dot and cross, we start from display formula, and in the syllabus they say that you're supposed to be able to apply the concept to other molecules, other compound, which you are applying to other molecules here. Carbon, group 4, it forms 1, 2, 3, 4 covalent bond. Carbon, group 4, 1, 2, 3, 4 covalent bond. Bromine, group 7, form a single covalent bond. Hydrogen, okay, 1 outer shell electrons, so it only forms single covalent bond all the time. Simple covalent molecule, simple covalent molecule, simple covalent molecule. This is minus 119 and this is 39. So if I have a number scale, maybe I can do it here. So I have minus 119, which is melting point, and I have 39, which is boiling point. So if I have 25 degrees Celsius, which is what you call room temperature, that is the region when it will be liquid. Okay, so NH3 is a gas at 25 degrees Celsius. Okay, HCl is a gas at 25 degrees Celsius, which means not NH3, not HCl. You're looking at B or C, because that thing is a liquid at at 25 degrees Celsius. See, all it comes down to is your general knowledge, and whether you can do this from topic 1, states of matter. Okay, the other two have very high melting and boiling point, so we're looking at MgO versus NaF, or SiO2 versus KCl. If we look at B, P and Q, P has higher melting point and boiling point than Q. Okay, so P has higher melting point and boiling point than Q. You can tell MgO has stronger ionic bond than NaF. MgO, Mg2 plus O2 minus, group 2 cation, group 6 anion, versus Na plus F minus, bigger charges, therefore stronger ionic bond. We talk about this, we discuss about this in the checkpoint question as part of the factors affecting the strength of ionic bond, which of course you did all the corrections and you revise everything before you actually sit for this test. Alright, as per what the syllabus require, there are a couple of questions that always compare MgO versus NaCl in the checkpoint questions, as well as in the work, the 4 different work we want to work for leading up to this test. So these are bigger and it makes sense, MgO and NF. SiO2, you need to break many strong covalent bonds because this is a giant molecular structure. It makes sense for it to be higher melting and boiling point than that. So that's not very helpful to me, that was only helpful there. But ionic compound, this is a giant molecular structure. We can look at electrical conductivity when it's liquid. This one, both of them conduct when it's liquid. Both of them conduct when it's liquid. This thing is giant molecular structure, so they do not conduct when it's solid, they do not conduct when it's liquid, because it's a giant molecular structure. Giant molecular structure do not conduct electricity, apart from the very special case study of graphite. Alright, that is 7. Which one is a pure substance? Alright, so consists of just one elemental compound, maybe. Has a low melting point, that indicates it's a simple molecular structure, but it does not tell you whether it's pure or not, because you could have graphite, you could have diamond. Those are pure because those are element, right? Different forms of the same element, which are called allotropes. They are different forms of the same elements, but they are pure, right? Because they only consist of only one type of atoms. So low melting point is definitely not correct. Is a mixture? Well, definitely a pure substance is not a mixture, because a mixture is impure substance. And then you have melts over a range of temperature is incorrect, because that is what happens when you have mixture. That means you don't have a fixed melting point, you don't have a fixed boiling point, so you must only talk about A. 38, we have three substances with the following properties, so we need to read very carefully. X conduct electricity when solid, so it's not ionic compound, it's not molecular compound, it must be a metal. It is not ionic compound. Alright, so C and D is out because you don't have free ions in the solid state. They are held in a fixed position in the giant ionic lattice, not free to move at all. So between A and B, so Y is soluble in water and the solution conduct electricity. So when you have MgO, you have Mg2 plus and O2 minus. When you have this thing called NaOH, the name is called sodium hydroxide. Those who were there for the holiday extra classes, I briefly talk about polyatomic ion. Polyatomic ions, so OH minus, alright? So it's OH minus. The whole unit there, this consists of two atoms. You don't get them from the periodic table anymore. There are lists of tables that you need to know the formula of different polyatomic ions, and they are the tricky one, alright? Y is soluble in water in a solution conduct electricity. Z only conducts when molten. Z only conducts when molten. Z only conduct when molten. I would think of Z being MgO. Okay, so even though this one is ionic between the two, alright, but this one consists of, if you think about it, this is water. This is hydroxide. This is an ion. This is a molecule. If you look very carefully, you will see that this is a covalent bond. And if you look very carefully, you will see there is an ion because of the charge. So these are the kind of things in polyatomic ions. You have both covalent as well as the charge there. So between Y and Z, I know that actually, eventually when you do practical chemistry, in all practical qualitative analysis, okay, you will always use something called sodium hydroxide aqueous. Sodium hydroxide aqueous. Sodium hydroxide aqueous is because NaOH is definitely soluble in water, and once it dissolves in water, you get Na plus and OH minus. They can conduct electricity. So the answer must be B there. MgO is not very soluble in water, okay, so MgO is not very soluble in water, despite it being ionic compound, because I did say that not all ionic compound is always soluble in water, but most ionic compounds are soluble in water. Alright, so 39, so we have, well, this is an easy one, sulfur. So we have two blobs of this, so there's two sulfur, and we have two of these, so we have two hydrogen, S2H2, so A and B are out. And this is a compound because the hydrogen and the sulfur are combined together. They are chemically combined in a fixed ratio. They are chemically combined. As you can see, there is a covalent bond. They are already chemically combined. Chemically combined because there is a chemical bond, covalent bond. Okay, so it's a compound there. Last question, finally. Alright, ethanol is a liquid at room temperature and pressure. Ethanol is CH3CH2OH. If I'm not mistaken, you have methanol in your syllabus under the dot and cross for covalent compounds. So you know how to draw CH3OH, which means you should be able to draw ethanol. But this question is really not asking you to draw, so you don't really need to draw in order to be able to do this question, because they say it's a liquid at room temperature and pressure. It has low melting and boiling point. So that simply tells you that it's a simple molecular structure. I have just drawn you the structure, but even without the structure, if I give you the formula, you should be able to draw it based on carbon being group 4 element. It form 1, 2, 3, 4. Carbon group 4 form 1, 2, 3, 4. Oxygen group 6, it forms 2 covalent bond. Each of the hydrogen forms single covalent bond. So ethanol is not an ionic compound. It's a simple covalent molecule. So A is wrong. we are looking at states of matter. Remember, states of matter is a liquid, and therefore it has low melting point and boiling point. So you need to think about structure, which is simple molecular structure, and what bonding are you breaking. Yes, you have covalent bond, but you do not break covalent bond when you melt or when you boil a simple covalent molecule, because you're just breaking the weak intermolecular forces, between the molecules. So the force attraction between ethanol molecules are strong. That is not true. They are weak. That's why it has low. Okay, the key thing is low melting and boiling point, because it has a simple molecular structure. You are breaking the weak intermolecular forces. That is called intermolecular forces. The force of attraction between the molecules are weak. All right, so there are forces of attraction between the molecules. It's called intermolecular force, and they are not strong, they are weak. That's why you have low melting point and boiling point. All right, that's it for this 40 question tutorial for the test on chemical structure and bonding. Some questions are more difficult than others. Remember that you have about 1 minute for each credit point in MCQ, and yeah, make sure you don't leave any blanks, but make sure that you don't guess randomly, because you must be able to read, underline, circle, I don't know, make notes or whatever. The answer is the important bit, but you must know that the answer is the best answer that you could think of based on you analyzing the question. Okay, a bad analysis will lead to a bad answer. Okay, it's very rare for people to get like 35 and above for MCQ out of 40, unless the student really knows what he or she is talking about. So if you can not get tricked by MCQ, it's very likely you would have done very well for chemistry. But it also said the same thing if you have done very badly for MCQ, that you need to improve very, very quickly. And why? After all the work that you have done, is it because you're bad at reading? Is it because you are very careless? Is it because you were working too fast that you should really double check your work? All those little things, they will add up to mistakes, and they will cost you in the long run. Okay, so thank you for watching, and let me know if you got any questions, and if you are not my student using this video, I hope that has been useful for you. I don't know, revising for your IGCSE or your O-level chemical structure and bonding. They will have been suitable for any 14 to 16 years old all around the world. Anyway, check out the other topical playlist as well for more chemical structure and bonding questions, and do relate to the previous topics on states of matter, on atomic structure as well. Okay, so follow me at ptet.chemistry on Instagram, Facebook, and Twitter to get all the latest updates on the channel, and don't forget to click the button on the bottom right to subscribe to the channel. Alright, see you in the next video.